Kia and welcome. Thank you for joining us on this Healthy Buildings Program webcast. Our focus today will be on learning spaces. My name is Kelvin Kennett. I'm the National Manager of AHI Carrier New Zealand. AHI Carrier is a top-tier air conditioning expertise provider through engineering robust solutions, supplying optimised equipment to the installation, tuning and ongoing support and maintenance. We can provide turnkey solutions through being New Zealand's distributor for Carrier and Toshiba equipment, supplying installation materials and spare parts through both our national network and locally through our total line trade stores across New Zealand, and our service team providing engineering, installation, routine and reactive support through our technicians and engineers working out of 6 locations across New Zealand. COVID has certainly highlighted the requirement for quality indoor air through filtration and ventilation. Along with carbon footprints, green credentials, life cycle costing and reliability, air quality will be a critical element going forward. AHI Carrier is introducing our Healthy Learning Spaces program. This includes an expansive suite of advanced solutions to help deliver healthy, safe, efficient and productive indoor environments. This will complement our role as leading global provider of reliable, effective and sustainable building solutions. As a founding member of the Well Institute, Carrier has long been an industry leader in enhancing building health to promote personal health. Now it is essential that New Zealand has solutions and services that enable healthy environments. Carrier, the company that invented modern air conditioning, is uniquely positioned to deliver healthy building expertise. As part of the Carrier organisation, our experts work closely with your team, not only design but operate, maintain and upgrade building environments that protect what's most important, the health of those inside. Following our overview, we will have 2 presenters today. The first is Steve King, who will focus on our service and support delivery options. Following Steve will be Hamish Flynn, who will cover products and equipment. Hello again. Keeping all people safe in learning spaces has certainly taken additional challenges since the advent of COVID. Through this slide pack, we would like to provide you with some information to consider as we all navigate our way through these challenges. Certainly the population of people working and attending learning spaces in New Zealand is significant at 830,000 students alone attending them. A strong short and long-term focus on spaces is required to ensure the safety of occupants is maintained. I'm sure you will agree that keeping all your staff, students and visitors socially distanced will be challenging. The experts are indicating that outside is the safest place to reduce the potential spread of COVID, though outside is not always practicable, in particular with our unpredictable weather. As we will still need to maintain learning spaces predominantly inside, I'd like to talk to you about air conditioning, heating, ventilation, air filtration in your learning spaces. Many learning spaces, including schools, are arguably of an old and just adequate design when it comes to ventilation and air conditioning. Additionally, and sadly, New Zealand is overrepresented when it comes to respiratory issues such as asthma, bronchitis and pneumonia. Along with the coronavirus, there needs to be a strong focus on improving the learning space environment. In the past, the primary focus has been on the reduction of energy usage balanced against the introduction of high volumes of outside air. So what does that mean? Fundamentally, the introduction of high volumes of outside air can result in additional equipment costs and energy costs. For example, on a cold winter day, it takes more capacity and energy to heat a room if we take in more of the cold outside air and less the return air. Therefore, most air conditioning systems are designed to use a majority of return air and therefore require less install capacity and reduced energy cost. A similar challenge can happen if the space has passive heating systems like hot water, panels, etc. We can appreciate that if the more outside air we take in, if it's a cold morning, the more energy we need to use to heat the room up to a level that's acceptable. The challenge, of course, is now that we are hearing that using more outside air is another good weapon against COVID. Unfortunately, a majority of our air conditioning systems are just not designed to provide this, either in capacity or the ability to distribute the air properly. So the challenge is what we can do about it. Let's refer to the Ministry of Education guidelines. So we can see in front of us, there's 6 main criteria. The first one is temperature. Generally, this has been the main criteria for schools. Again, it's generally provided by passive hot water systems, heating panels, or through an air conditioning system with heating and cooling coils in it. The second one is safety. It refers to low volatile organic compounds. Basically, nowadays it's generally found in the finishes and in particular paint. You'll find that most paints nowadays have got low VOC emissions on them. So we're good there. Again, as we know, we're aware that some of the older schools and old facilities have got lead-based paint. So be aware of that. Moisture. So they're saying a humidity range between 40 and 60%. So for those of us who live in Auckland, we'll sort of recognise that it's often quite moist here. So 40 to 60% is often on the nice side. It would be rare that any systems outside medical centres or data centres would have an air conditioning system that would provide either the humidification or dehumidification. The fourth one, air quality. Air quality, along with mechanical ventilation and filtration, will be a strong focus for us all going forward. Air quality can generally be influenced by the amount of outside air entering the space, either mechanically through ductwork and fans or through opening windows and doors. It's also influenced by the level of particles and contaminants in the space as well. Next one is mechanical ventilation. This is the requirement for spaces that rely on mechanically provided outside air through fans and duct systems. So if a building is a sealed building, the windows can't open, it needs to have outside air introduced to it through a mechanical system. If the room has got opening windows, then the requirements are that it doesn't need mechanical ventilation to introduce outside air because it can provide it by opening the windows, assuming we open the windows. So if we put in context, we can see the filtration there is saying that we need the mechanical ventilation there is saying we need 8 litres per second per person. So if we put in context, 8 litres per second per person would be equivalent of 4 2-litre milk containers of outside air per person per second. If we expect 30 people in a classroom, for example, then it would be 120 2-litre milk containers of outside air per second. So it's a fair amount of outside air that we would need, and that helps flush out the building and keep providing the fresh air. And as we know, if we listen to the experts, it means that the COVID virus, which transmits itself on droplets of moisture, is more dispersed and less likely to affect the people. Filtration. So if we look at filtration, it's basically the method of filtering out the small molecules. And certainly this has a great effect on reducing the spread of the viruses and other ones like to do with bronchitis and the other diseases and challenges that we know of. So if we look at air filtration in particular, so if we remember on the previous slide, it said it wanted a MERV rating of 7 to 8. So we can see in front of us here a fairly simple table. So the MERV rating is the minimum efficiency recording value. HEPA is a high efficiency particulate air. So we can see here that we, like most people, we like having acronyms and all that. So there's a lot of talk about HEPA filters at the moment, and they're basically very high efficient filters. They are up to 99% efficient at knocking out most things that can come around through in the air. So therefore, they're used a lot in surgical areas, in surgeries, in operating theatres, etc. From what I can read, the size of a COVID virus is about 0.12 microns, which is really small. To travel, they have to attach to a watertight molecule around 4 to 5 microns. So on their own, they don't seem to travel, but when they connect into a water vapour, then they can travel around. And if you sort of think a common cold and flu, they travel in a similar method. If someone has it and they sneeze out, the water particles that they sneeze out generally or can contain the virus molecules in them. So if we look at MERV 7 to 8, we can see that it's not really the best filter there is. And when it comes to the 3 to 10 microns, which is in the 1, 2, 3, 4th column, we can see it's good for, let's say, 50 to 85% of them. And that's the sort of size we're looking at to try and filter out. We can see as the MERV rating increases, when we get to the 13s and 14s, we're getting into the superior commercial filters. And a lot of air conditioning units nowadays are actually installed with a higher MERV rating. However, if you go up to the HEPA filters, which are in the last rows, we can see MERV rating of 17, 18, 19, and 20, and they're good for 99% of trapping the particles. So we can see that having the higher level of filtration is better for us. So the challenge is that the higher the level of filtration, the more static pressure that you have in a fan system. So it's a bit like if you had a fan and you had to blow the air, a certain volume of air through a cheesecloth, then we can appreciate that that needs X amount of energy, not a lot of energy. But if we change that cheesecloth out and put a blanket in there, i.e. a high grade filter, we can see now that the fan has to be stronger to push across the same volume of air. So that is a bit of a challenge that we have. What are our other options? Options for portable freestanding air scrubbers. So, and Hamish will talk much more about these. So basically it's a fan with a high quality HEPA filter in it. And it certainly can provide an increased level of protection through better filtration. They're a bit like a commercial looking oversized humidifier. You may have one at home. It comes on wheels. It's just it's a large box on wheels that does its duty. Another setup that's been discussed is negative pressure. So what does a negative pressure space look like? Generally, these are spaces that you'll find that are set up in hospitals and medical centres and infectious disease areas and now MIQ spaces. So the aim is to keep the contaminants within the room. So the way we do that is we make that room negative pressure. So if someone opens the door, the air tends to follow the person in rather than follow the person out. So how do we do that? We run an extract fan system such that that room is under negative pressure compared to its adjacent rooms. And that can be controlled. So it's not so you can't open the door, but it's on a slight negative pressure. And also by, of course, having the room so it's relatively sealable. Otherwise, you'll need lots of fans to keep it under negative pressure. So I guess a simple example is a toilet. So I'm sure in your offices somewhere you'll have a toilet. There'll be a toilet extract fan that's doing roughly about 100 litres a second extract, and your doors are sealed, and they'll have a grill or something in the actual door into the corridor, which of course will let the air come in to make up for the air going out. So it's a negative pressure, and so basically what it does, it sucks the fumes to outside rather than letting it in the corridors or to the other offices or whatever. So clearly that's a good design. Arguably, if we take a toilet, it's relatively small space, arguably. If you want to do a negative space to a classroom, we could appreciate there'd be a lot more involved with that. The other part with introducing outside air is the CO2 levels or the oxygen levels. So as we know as humans, we like oxygen, we don't really like carbon dioxide. So we can appreciate that if we don't have good ventilation, then the room is like, and there's people in there, so a classroom, it's closed up because it's a cold winter's day, and it's been closed up and people have been in it for 3 hours or whatever it's been, then we can appreciate that the carbon dioxide level will increase and the oxygen level, of course, will decrease. So what does that mean? So I'm sure we've all been in a room somewhere or a restaurant or where there's been it's been closed up and lots of people in there for a long time. So we always start to feel sleepy, we yawn a lot, we struggle to concentrate. So that's another good advantage of having good quality outside air being brought into any space. If we look in front of us, and yes, it's a few years old, but I suggest it probably hasn't changed that much. So we did a study in New Zealand of 12 naturally ventilated classrooms. So these are classrooms where there's no mechanical ventilation, so it relies on the windows to be open. No great surprises. Damp conditions led to concentration of fungi and bacteria. We can see that. We live in quite a humid country, especially us up north, and arguably some of our buildings are not particularly well insulated, and therefore we do get a lot of damp conditions. Passive ventilation may often fail to provide ventilation to the required standards. What does that mean? It means on windy, cold days, we want to keep the warmth inside to keep the occupants warm, so we close all the windows. We can appreciate if we open all the windows, that's a good thing for ventilation, but unfortunately our heating system would be totally inadequate. Classrooms require at least 10 times more outside air than houses due to their occupancy rate. So we can see that at 8 litres per second times 30 people requires a lot more outside air. Correctly installed air conditioning, mechanical and control systems with outside air introduction can help. So what does that mean? It could be a ducted system up in the ceiling, a fan coil unit, which is basically what it sounds like, a fan and a coil. It introduces air into the building, into the space. It takes a combination of the return air and outside air to actually supply the air into the space. So we can see that having a system that can do that certainly helps in retaining oxygen levels, reduces mold, reduces the spread of viruses while keeping good quality conditions in there. So we can see on the right-hand side, there's a graph, there's a table there and a graph there that sort of indicates those things for us. Learning centres, considerations and solutions. So if we have a look at it here, this is an American study. You could argue it's probably fairly prevalent wherever you go throughout the country. If there's a high concentration of particles and everything there, there's your increased prevalence of asthma. We could understand that. Infection control strategies could cut average number of measles infections down. So again, air filtration, ventilation and purification can help in that. As we said before, the poorly ventilated classrooms, power of attention generally relating to CO2 levels. Taking exam, as we can appreciate, if it's 32 degrees outside, it's a lot more uncomfortable than 24 degrees, so people are likely not to do quite so well. And the last one is really safety, staff retention. So generally, if we have good facilities, people feel a lot more valued and a lot more engaged with the school. So my last slide, so thank you for listening. So just a couple of points to note here. Increase fresh outdoor air by having windows and doors open as much as possible. Purge rooms by opening windows and doors prior to occupancy and during breaks in occupancy. So open the classroom up for, let's say, an hour or even 20 minutes or even 15 minutes before it's occupied in the morning. Then if you open it up again during the breaks, so your morning tea, lunch and afternoon tea, that helps the room get purged of its stale air and you bring in some fresh air. So that's a good, that would be a good practice I would suggest that we should be looking at now. If you've got a ventilation system, make sure it is operating properly, make sure the filters, of course, are clean, that if there's outside air, the outside air dampers or however it gets its outside air in there is open and working correctly. If there is outdoor air dampers, so these are dampers, there's basically a set of louvers, if I put it that way, that actually you can adjust to allow either more or less outdoor air in. So if it is available, check that they're okay. Central filtration, so we've talked about that. If we can increase the quality of our filters, that's a great benefit. The challenge often is that the air conditioning unit, the existing air conditioning unit, just doesn't have the physical space to do it, and fan may not be strong enough to overcome the additional resistance. As we said before, run HVAC systems at maximum outside airflow for 2 hours before and after school. So if it's a sealed room and it relies on outside air being mechanically introduced, then just run it a little bit earlier to try and purge out any stale air that's in there. In some cases, you can get demand controlled ventilation systems. So basically, if you had a room, let's say a large meeting room or something like that, that had a CO2 meter in it, then it would sense when the CO2 is increasing, as in when people are in there and they're in there for a while, and would start to open up the outside air intake to provide better quality better quality outdoor air. There are ultraviolet germicide irradiation filters as well. There's electrostatic ones and other types of filtration that is of good quality. You can consider using those. And lastly, if you are retrofitting and installing new systems, to consider having a system in there that has the ability to provide good volumes of outside air to suit the actual occupants levels. So that's the end of my talk. I will now hand over to Steve. Thank you for listening.
Hi, I'm Steve King. I'm Service Key Account Manager and also responsible for Smart Service and Digital Solutions here in New Zealand. We'll start with some information around indoor air quality testing and assessments. Safe start services. Many building owners and operators may be unsure how to move forward in developing a healthy building strategy. That's why through our BLUEDGE service offering, AHI Carrier is here to help, starting with assessments across all aspects of your building, reducing risks of unexpected equipment downtime and proper equipment startup, simplify short and long-term budgeting with planned extended warranties. Also asset protection to ensure long equipment life. Emergency assets, we're here to ensure all critical assets are available when needed and meet all indoor air quality requirements. Air quality assessments. We want to provide a workable strategy to allow upgrades to meet your facilities requirements and standards. The assessment itself, we carry out assessments to well building standards, which are generally accepted as a very well performing system. Linking building security as part of any robust quality assessment is a logical manoeuvre as well. What do we offer? As AHI Carrier, our service offerings start with just general service repair. So any of our HVAC and chiller plant equipment that needs repairing, whether it's a one-time, one-off repair, or whether it's a part of a service package, we're here to support all of the customer base. Service modernisation based around utilising the equipment you already have and maintaining it through its full lifespan, and then coming up with a solution to provide a replacement, whether it's a full chiller itself, whether it's just the pump system, maybe it's some fan core units, maybe it's an air handler, even cooling towers, or a full new control system. This is all available through service modernisation. Predictive maintenance contracts are primary in any guarantee of operation of any building. The ability to plan for a failure, a plan for a replacement, is all based around predictive maintenance. So our planned predictive maintenance projects and programs are always based around what is best for the building itself. These tie in with service agreements. Any planned service agreements that we hold gives you access to all of the periodic analysis and reporting for the equipment, and also giving you full 24-hour coverage for emergency call-outs. Service retrofit packages are a replacement for a full replacement of a piece of equipment. Repair and overhaul is something that's still possible for lots of aged systems, be it a full chiller plant, HVAC and control systems. Sound calibration and a lot of other non-destructive testing services are all offered by Carrier. In HVAC equipment, baseline analysis can provide a remarkably detailed picture of many different mechanical problems, even in their earliest stages. So actively testing with vibration, noise levels, balance conditions will all lead to an early onset failure reduction of the equipment. And this is available for both non-carrier and carrier equipment. Adiabatic cooling is becoming more of an obvious choice in a lot of higher ambient locations, because it provides better energy usage and obviously going forward a healthier building full stop, with the less power used to produce the cooling effect that you require. It also works in locations where chillers are being built in a building environment where they get lack of airflow around them, some very reduced airflows, becoming more and more so with the abundance of equipment that is placed on a roof and around in the location of a chiller. Adiabatic cooling can help with this and make it the chiller more efficient. Duct and filter cleaning is another prime example of a healthy building environment. Clean filters, we know, is a far healthier thing in a building, full stop. Duct cleaning gives you more effectiveness and efficiency of movement of the air, which makes it the system work a lot more efficiently as well. Remote management. We spend up to 90% of our time indoors. For building owners and managers, this means buildings must continue to be a safe place to work and support the health and well-being of occupants, all the while keeping an eye on building operation, occupant comfort and energy efficiency. The way we do this is by remote airside management. This focuses on HVAC efficiency, specifically maintaining different parameters such as space temperature, relative humidity, and level of CO2, ventilation rate checks and availability of filters, i.e. checking pressure drop across filters, making sure there's no blockages, making sure there's correct amount of airflow going through the system, all aids the indoor air quality. And remote monitoring offers this in real time in many cases. How we do this is through any buildings management system existing. The Cortex platform that we utilize is a predictive, actionable insights based system. So it has a set of parameters that it's looking at all of the time. What it's trying to do is to maintain them. So what it does is it assesses what is and isn't working correctly and sends a signal advisory reports to our command centers. These command centers could be it can either go through our command center or be utilized off the web and app portal directly through Cortex for the customer to do this. The other option is that the command center will monitor on periodic basis what the building management system is doing and make changes and report on those on, say, a weekly or monthly basis. The Cortex system is continuous monitoring. So rather than assessing what might go wrong, it's checking against a lot of different parameters all of the time. If a simple process is just to check that the temperatures on the floor are accurate enough to all of the units, there's no wavering and variation on the temperatures, that can be monitored directly through the command center. They can go in, take average readings at any time. Cortex would do it on a live system, so it'd be recording all of the time and seeing a deviation in that. The higher level would be to go to the operation of the units themselves on site and ensure they're working correctly, i.e. the fresh air supply fans are all running to the occupancy standard that you set for the building. That equipment is supplying to the temperatures that have been set for the building and through the parameters, or directly into the high level point of an air handler where you'd want to know that the fan is working correctly, the heaters are working okay, or that you've got a filter that is blocked, you've got a dirty filter, so the pressure drop over them is indicated and notified straight back to the system. Remote energy management, from lighting to heating, ventilation and air conditioning to a number of other building systems. Our Cortex platform uses IoT connectivity to track performance data and trends, then contextualizes that information and provides advanced insights to users to drive optimal performance and efficiency. The system does this in the same way as the Airside by utilizing your points on your BMS in the system. The difference this time is that the Cortex system is running autonomously, pulling the information out and seeing how much power and energy is being used for certain pieces of equipment. What it does then is if the piece of equipment goes outside a set parameter, it has the ability to go in and change that parameter live on the BMS. So managing the energy efficiency and maintaining it to the same standard. It also has a smart dispatch system on there so that when it sees an issue it cannot resolve or something that needs to be reported, which is selected, it will send information to the command center. So they can then action that and review what changes need to be made or what have been made on the BMS, and in some cases override them, depending on the reason for that deviation from standard. The command center will then actually send that detail out to the building operator, the building technicians and the FM as well, just to let them know what's going on and why they did what they did, and send advisory reports with it. The two platforms working together make sure that the building operates to the best ability it can, recording the same energy usage where possible. HVAC remote services. Now, remote services improve productivity with real-time machine health. Notifications, analytics are connected HVAC assets providing data on demand on web mobile devices. At present, our systems work primarily with chillers, so this is our remote chiller access, the Carrier Smart system. As the equipment, a new equipment comes out with the new connectivity system built into them, there'll be more product added to this as well, other than just chillers. At the moment, the Carrier Smart system uses wireless technology. Carrier Smart Service connects any Carrier chiller to the cloud and streams operating data, providing ongoing insight into the chiller's health and performance. We can diagnose issues and failures live prior to any technicians needing to be dispatched to the site in some cases. In some cases, we don't need to go to site at all. We can actually communicate the information that's required to be changed directly to the building managers, the building operators. Without attending site, we have then solved an issue without interrupting their operation at all. There's no requirement to connect via a customer's network. The secure wireless connectivity to Carrier's cloud-based platform, the standalone connectivity package only captures key operating data and does not remotely make changes. It's a one-way stream only, so there is no security issues with communication both ways, and equipment being able to be turned off or temperatures changed remotely. It doesn't work that way. It is purely for capturing that information. The smart technology automatically shares this information with Carrier technicians and facility management teams who have access either by the app or through equipment dashboards on the web. These teams can then address the potential issues, resulting in more uptime and reduced repair and downtime of the equipment. And monthly service reports are supplied, and trend logging where required as well, which work hand in hand with asset management and energy management reporting as well. So just to recap, assessments will allow your indoor air quality to be managed efficiently and to industry standards. System monitoring ensures optimal operation of assets. Remote diagnostics provide opportunities to maintain operational policies and procedures. Maintain compliant air quality with asset condition monitoring. Control your resources by remotely monitoring and adjusting building needs. Gain control totally with reporting and metrics based on identified and solved issues dispatched to technicians or directly back to the system. If you have any questions, please make contact if you'd like more information, and thank you for listening.
Hi, and welcome to AHI Carrier Healthy Buildings, Healthy Solutions. My name is Hamish Flynn. I'm the National Commercial Sales Manager for AHI Carrier based in Auckland. Today I'll be taking you through the air quality solutions for schools, office blocks and hospitals. These solutions are brought to you by the range of products made and designed by Carrier. Part of this lineup, we're going to be covering negative air pressure and air scrubbing solutions, airside equipment and filtration purification technologies, and building controls, brought to you by Carrier. First up, we have the OptiClean. The OptiClean machine is a product that was designed and developed by AHI Carrier in the US to fight against the outbreak of COVID-19 in 2020. The OptiClean machine is a portable air scrubber or negative air machine. This machine can do up to 315 litres per second and has a static pressure of up to 140 pascals. This can be hooked into ducting within the room or just used as an air scrubber machine. There's a 3-pin plug designed for 50 and 60 hertz. So obviously New Zealand is 50 hertz, so it complies with all New Zealand standards. The machine is 1.2 meters high by 400 wide by 500 deep. So it's still quite portable and compact. The machine has 2 grades of filtration. It has a G4 filter, pre-filter, and then also has a HEPA grade filter in the middle of the machine that lasts up to 40,000 hours. This machine is great for schools and universities and office blocks, or office spaces, as it can be moved around, and it is very portable. It's a roll-in solution compared to having to manufacture and install large ducting within the space. These are available shortly. We are currently taking pre-orders for these machines, and these will be available early 2020. Little short video just to show you what the OptiClean is all about.
We spend approximately 90% of our time indoors, which is why at Carrier, we're always looking to the future of healthy buildings, developing products that help make our indoor air not only comfortable, but cleaner and healthier as well. That includes Carrier OptiClean, a portable filtration system designed to actively improve indoor air quality. And since it doesn't require ductwork, it's ready to roll into healthcare facilities, offices, and schools. OptiClean pulls in air from the surrounding area and passes it through HEPA-grade filtration to remove 99.97% of contaminants as small as 0.3 microns that flow through the filter. It then recirculates cleaner, filtered air back into the room, so everyone can rest assured knowing the air around them is healthier. Carrier OptiClean. It's just one more way we're redefining the future of indoor environments today.
As mentioned, we are taking pre-sales on these particular items, and we do have one on display in our Auckland office if you wish to contact myself or the team to arrange a viewing and to see what it's all about. Next up, we obviously need to talk about isolation rooms with the current Delta outbreak within New Zealand and Auckland. There is a need for additional beds in isolation rooms, and obviously to protect us in the future. Carrier has a wide range of AHUs available to the market. Carrier also prides itself in hospital grade AHUs throughout the world. Part of this range is we've got the 39HQ. 39HQ can be designed to your needs, and it is a modular AHU. We can have different 95 standard sizes, and then we also have a lot of combinations, so these can be customized to your requirement. These can be but not limited to filtration, advanced filtration, single or dual stage, up to HEPA grade filtration. We can have hot water coils, DX coils, cooling coils available. We can also have high UV lights installed in the filtered chamber and before the coils. We can have multiple EC fans available, and also they can be connected to our 30 RBR, our new R32 AquaSnap chillers, and they'll also have their own standalone communications. These are great for obviously negative air pressure isolation rooms, or in general your hospital or healthcare facilities, or any other processing facility that requires air filtration. All our AHUs adhere to ASHRAE and international health facility guidelines, and so we can make something up to your requirements. Just touching on the different types of filtration in the UVC light. UVC light is a product that can be installed into AHUs or air handling products or package units in front of the coil and in front of the fan or after the coil. This is going to protect and help maintain a healthy air environment. By installing UV lamps, this helps with killing any mold, bacteria, and microorganisms from the equipment surface, and reduces your maintenance cost, but also improves your air quality. Just touching a bit further on filtration. So filtration for hospitals and pharmaceutical, food processing, schools and universities, and commercial buildings. Carrier has a wide range of filtration options available to you in their AHUs and in their package units, from compact filtration to carbon filters, chemical filters, and all the way up to HEPA filters. Biggest thing is making sure that your pre-filters are kept clean and changing these on a regular basis to protect your HEPA grade filters or your advanced filtration. They're the ones that cost the most. A little bit more on filtration. We've got UVG or UVC. We also have bipolar ionization. So it's an ionizer. It's emitting ions, negative ions into the atmosphere. Also have high voltage electrostatic filtration. This is again can be installed into your AHU or package unit, and photophytalic air purification. So we have a filtration option available to everyone's needs and spaces. Touching on our 50 UPV rooftop package unit. This rooftop package unit can be available between 25 and 290 kilowatts. It has a compact size from 2.1 to 2 by 2.4 up to 5.8 by 2.2. It stands from 1300 up to 1.5 meters tall. So it's quite a compact AHU or rooftop package unit. Main features of this package unit are has inverter compressors. So they are a Danfoss compressor with an inverter drive fitted to it. It is controlled by Carrier Touch Pilot Control Interface. So this means the AHU or rooftop package unit can be controlled remotely and standalone. Does not need anyone else's third-party product to be attached to the machine to be able to control it. It's made up of double skin indoor side panels with 60mm all glass with aluminum foil for additional thermal protection. The outdoor panels are coated with 13mm thick rubber insulation to help with the outdoor environment. High quality paint job, polyester powdered paint with 1.5mm thick galvanized steel. Also, we can provide additional protection within the factory to the filtration chamber and on the coils to protect in marine environments. We have a wide range of filtration options, single stage or dual stage filtration, right up to F9 if required. We have what's called EC condenser fan motors as well as supply fan motors. we can have these as low noise as well. Now for our supply and return options, we can have supply and return on the bottom, supply on the top, supply on the side, and return on the back. So that's should be able to meet most of your requirements. We can also have a booster plug fan in the return or return air if required. We can have an additional cooling coil or heating coil within the package unit. We can have heat recovery wheels. We can have economizers and booster heaters for the low ambient conditions. If you need any further information on these particular units, please make contact with myself and my team, and we're happy to provide you a selection. Continuing, we have partnered with AquaAero. AquaAero has developed an anti-bacterial coating that can be applied to the indoor coils of our package units. They also have an additional coil treatment for marine environments. This can be up to 10,000 hours of additional treatment of the coil, of indoor and outdoor coil applications. All approved, as mentioned, so it has a 10,000 ASTM B117 salt spray test certificate. It has standard full UV protection also, and has different levels of different grades of salt spray and antibacterial requirements. Water-based, so it's good for the environment. Next up, so we have our air quality sensors by our iView product, not limited to just CO2 sensors, but this is part of our air quality range. Carbon dioxide sensors are a critical tool in checking indoor air quality to ensure your building is operating correctly. This can be linked with our iView building management system to also provide building control. As mentioned, Carrier iView has a full building automation program and can provide you additional support for your third party and your Carrier products throughout your building, and can be integrated into any system. Again, if you need any further information on Carrier iView or Automated Logic products, please make contact with myself or the team, and we'll provide you with relevant information. I thank you for your time. As mentioned, if you do require any further information on any of the products you've seen today, please make contact with myself or my team. Healthier future starts indoors. Thank you.